This is part 2 video for naming ionic compounds. So if you have your periodic table, your reference packet, so you have your periodic table and your polyatomic ion list, get that out. And if you have my packet, this is page 8. So what we're looking at here, these are all ionic, so they have a large difference in electronegativity, so it tends to be a metal combined to a non-metal or something that involves a polyatomic ion, so you're going to get charges generated. So we have to pay attention to those charges. Now I'm not going to do all of these examples, but on the left, when you have that is binary, that first one there. It's Na2S. There's only 2 elements in there. So I'm going to write B for binary. Now what you want to do when you're naming an ionic compound is find the metal first. Always look up the metal if there's a metal in there. So find sodium on the periodic table. Look in the box for sodium. It does not have any numbers in the upper right hand corner. Now that's going to make this one easier. That means you do not need any Roman numerals. You just have the name of the metal, which in this case is sodium. And since it is binary, the ending becomes IDE for the anion. So you get sodium sulfide. Now the next 2 down are pretty similar. They both have sodium, but they are ternary or tertiary if you want to think about it that way. They have a polyatomic ion. So now you have to check your polyatomic ion sheet. And notice one ends in 3 and one ends in 4, and that's going to play a big part in this. So SO3 is sulfite. SO4 is sulfate. You do not change those endings. It's just whatever the polyatomic ion is. Now if you look over on the right hand side, you have calcium phosphide, calcium phosphite, calcium phosphate. Always find the metal first. So you find calcium. It does not have any numbers in the upper right hand corner, so the only oxidation number is +2. So when you're doing an ionic compound, get the metals first, get the oxidation numbers. Now phosphide, since it ends in IDE, it is binary, so you just get it from the periodic table, and it's phosphorus with a -3 charge. So now you crisscross the charges like we did in the previous video. You have Ca3, P2. Alright, for the next 2 down, they are both calcium, they're +2. Phosphite is PO3 with a -3. Phosphate is PO4 with a -3. So the difference is those numbers, the subscripts there, 3 and 4. So when you crisscross these, you get Ca3, PO3, but you need parentheses around that phosphite because you have more than one of them. So for calcium phosphate, the 3 from the phosphate gets written as a subscript for the calcium. You have to put that phosphate in parentheses because the 2 from the calcium gets written as a subscript there. Now I'm going to scroll down a little bit. Get into some harder examples down here. So all the way down at the bottom, 20, 21, and 22. These are metals that are multivalent. So for FeCl2, and I'm going to write this a little bigger here, iron can either be 2 or 3, so you have to figure out which one it is. Now, we have to know what the other thing in there is. We know chlorine is a -1 charge. Now, there's 2 of them, so the right-hand side is supplying a total of -2, because each chlorine supplies -1. Now, that means the left-hand side has to be +2 to balance it out. There's no subscript written here for iron, so that means there's only 1 iron in there, so that whole +2 charge is coming from that 1 iron. So you get iron 2 chloride. For PbNO3 Pb, and I'll do it right here, could be at 2 different oxidation numbers. Right? So check your periodic table. It tells you that could be, it's multivalent, so we have to figure out which one it is. Nitrate is -1, but there's 4 of them. So the right-hand side is a total of -4. So the left-hand side has to be +4. Now there's only one lead in there, so that whole +4 is coming from that 1 lead. Now what happens is, sometimes at this point people think, well, I could just take whatever the subscript is for the polyatomic ion and say that is the charge for the metal. And it doesn't always work that way, because remember, you can reduce to subscripts. So let's say you were working with something like this. This is not one of the examples, but it's a good one to go over. You have PB SO4 in parentheses with a 2. Alright, so sulfate is -2, but there's 2 of them, so that's a total of -4. So the other side has to be +4. Alright, so you get something like that, +4. So you get lead 4 sulfate. Where if you were taking a shortcut and you said, oh, well, there's a 2 right here, and I know I have to crisscross the numbers, so it would be lead 2 because of that. You can't take that shortcut. It doesn't always work. Make sure you go through this math to figure out which one it is.